Welcome to the Real Python Podcast. This is episode 210. What techniques go into synthesizing a guitar sound in Python? What higher-level programming and Python concepts can you practice while building advanced projects? This week on the show, we talk with Real Python author and core team member Bartosz Zaczyński about his recent step-by-step project, Build a Guitar Synthesizer, play Musical Tablature in Python. Bartosz shares how he had built an early prototype of the guitar synth using a different language. He describes recreating the Karplus-Strong algorithm in Python to create the plucked guitar sounds. We discuss teaching advanced Python concepts while guiding readers through constructing a complete project. We also dig into reading and writing WAV files in Python, using Spotify's pedalboard library, implementing poetry in a project, and designing a file format for guitar tablature. This episode is sponsored by Mailtrap, an email delivery platform that developers love. Try for free at mailtrap.io. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Bartosz, welcome back to the show.
Hey, Chris. It's good to be back.
Yeah, we had you, I don't know, it was maybe a couple months ago, but you've been very busy writing a couple interesting projects that definitely are up my alley. You did 2 articles that are sort of deep dives into the audio side of Python. Your first one was the reading and writing WAV files in Python.
That's right.
You want to talk a little bit about that?
Yeah, sure. So why don't I start with saying about the motivation and what were my goals for writing this tutorial. So I wanted to show that Python has this little known module in the standard library that is quite powerful because it lets you do rudimentary digital audio processing or even sound synthesis without having to install third-party libraries like NumPy. And besides, someone on the team, I think it was Martin, found a quote by David Beasley, the author of the Python cookbook, who once said that the WAV module in Python, which is what the tutorial is about, is fun and easy to teach to kids and can make crazy sounds. And that's a powerful and highly motivating exercise for aspiring developers. Other than that, I picked this topic because I wanted to take a break from these longer deep dives that I tend to wind up myself in. And instead, I wanted to write a shorter guide, focus on a relatively simple topic that might be interesting, but perhaps not very well known.
Yeah.
And this didn't exactly work out because the article ended up being over 15,000 words.
Yeah, you found some interesting stuff to talk about.
I did, didn't I?
Yeah.
it goes way, way beyond just reading and writing the audio files. And you already summarized the scope pretty well a few episodes back. But I can quickly mention that the tutorial ends with a few mini projects, if you like.
Yeah.
Based around the WAV module, and 2 of them implement some popular audio visualizations. One is an animated waveform in the time domain, and the other one is a spectrogram in the frequency domain.
Yeah.
There's also an internet radio stream ripper, which lets you record a live stream onto a disk as a WAV file.
I had to say that was totally out of left field for me. I was like, and we're going to do this. I was like, okay, cool.
I just couldn't resist doing this one. It felt, like not very much, not a lot of effort to make it. So I thought, why not? And finally, there's also a script that widens the stereo field of an existing recording to make it sound more three-dimensional. And apart from that, I've included a very simple sound synthesizer that can simulate some interesting physical phenomenon when you mix certain frequencies together. So
yeah, you made like kind of phone sounds and things like that. It was very interesting.
Well, I was talking about the beat. So when you mix 2 frequencies together, which are very close to each other, it makes this interesting effect. And I won't spoil it. So you can go ahead and read it.
People should check it out. Yeah, and I did talk about it because I was very interested in it at the time. So yeah, a little bit of a repeat there. But what I was thinking about in that process that I didn't get to ask you is, well, what were things that you wanted to learn in the topic? Was it the WAV file module, or were there some other things? Obviously, you went off and explored lots of things in the process, but what were things that at the core of it that you wanted to learn?
Good question. Well, honestly, there was nothing in particular that I wanted to learn because I thought that covering such a simple topic as reading and writing WAV files wouldn't present any rabbit holes and that I wouldn't learn anything new along the way. But there was actually one thing that surprised me, and that was the handling of the 24-bit PCM encoding. So
Okay, yeah.
most WAV files are fairly simple. They start with a header, which contains a bunch of metadata, such as the number of channels, the sampling rate, and the bit depth, or number of bits per sample, which determines the dynamic range or the number of distinct amplitude levels you can represent. The rest of the file is just a sequence of uncompressed frames, which contain the individual audio samples for each channel. Now, the most common encoding scheme for these audio samples involves 16-bit signed integers, which are fairly standard, and they're widely supported both by hardware and most programming languages. Even though Python doesn't inherently have a corresponding data type, you can still use some standard library modules like struct and array to work with those foreign numeric types. In fact, any numeric data type that allocates a number of bits, which is a power of 2, is pretty straightforward to work with. But these powers of 2 have a downside, and if you want to improve the dynamic range of your audio recordings, you have to go from 16 bits to 32 bits, which suddenly doubles the amount of storage required. And while storage is not such a big problem these days, right? Bandwidth is. So services like Spotify that stream audio data over the air are very much interested in finding a middle ground between good quality and download speed. So when they stream data, they want to use the least number of bits per sample as possible while still maximizing the sound quality. To do that, they often use somewhat exotic bit depths that are not powers of 2. So the WAV file format happens to support 24 bits per sample, which adds only 50% of storage, but at the same time, it offers as much as 2 orders of magnitude better dynamic range.
Yeah, it's dramatic, yeah.
Unfortunately, Python's WAV module doesn't support this encoding out of the box, and my tutorial goes into detail showing a few alternative ways how you can interpret such 24-bit integers, as well as how to encode them back into WAV file. At first, it shows how to achieve the desired result using pure Python, which is elegant but slow, and then it follows with a slightly more complicated implementation based on some NumPy tricks, which are much faster. I don't remember exactly how much faster, but it was significant. So that was one thing that I didn't know that I wanted to learn.
Yeah, that's cool. Yeah, I feel like you're expanding upon what is available in that WAV module, but also then kind of thinking about like, okay, well, what are other tricks that people can kind of learn? I feel like that's something that you do often in your tutorials, that you are interested in a subject and you want to give people something fun and almost sort of tangible to kind of play with and create. But at the same time, well, maybe we can learn these concepts about structs or about immutable objects, and how you literally got a question from Christopher Trudeau about lists, which I thought was great. The whole idea of making lists of lists. And then he said, oh, I actually use that in my tutorial. And
that's right.
And that's, I think a lot of times what happens with like, why should I learn this topic is like such a common thing that maybe a young student would have. Well, you can use these things. And having those examples ready isn't always there for a lot of instructors. And so it's nice that as you're digging through this, you're like, oh, and I can teach about this concept.
Yeah, I couldn't say it myself better. I always want to promote good programming practices, idiomatic patterns, and modern Python features. I know that this may sometimes mean that people running previous Python versions won't be able to fully follow my tutorial, but I still think that it's beneficial and also a great opportunity to get out of your comfort zone and try something new.
Yeah.
So I can't remember a lot of details about the WAV file. I don't recall any particular like coding techniques. I think the highlight was using NumPy, but there was quite a few actually features from Python and programming techniques in the other tutorial that we haven't talked about yet.
Oh, definitely. Yeah. But I do want to highlight that if you're maybe not super interested in creating raw wave files, but maybe you work with audio and you want to do things like plot the waves. You do this whole section, again, I already spoke about it on the other episode, but about plotting the waves in Matplotlib, which I thought was really great. And then it was really fun kind of watching you work and build these visualizers, the spectrogram and the other one that was sort of playing the waveform, creating these cool bouncing displays. So what were the types of things that went into researching that?
You mean the wave file or the visualizations, the animations?
I think the animations, yeah. Like what were things that, were there libraries that you had to add, or were they things that you could find?
Yeah, if I recall, I use Matplotlib for rendering. And I think Matplotlib has this functions module or animations module or something like this, which lets you plot the subsequent frames and make an animation out of it. So that's what I used, but I always find working with Matplotlib a little challenging. I find their API to be not the best, not the most intuitive in the world. So I always check the alternatives, but end up using Matplotlib anyway.
It's nice because it is kind of a core to like what you can do is graphs and plots, but it feels like it almost, I mean, it would be painful for them to do this, but to sort of reorganize it, it feels like things have been a bit bolted on as they've gone. And so like the problem with plotting and graphing and adding animations and things like that is maybe their overall model didn't necessarily fit all those things, and they've been added as they've gone along. So I kind of agree.
There's this other library called Seaborn, which builds on top of Matplotlib.
Yeah.
But it unfortunately focuses on statistics, so it's not as universal as Matplotlib. But I wish someone created like Matplotlib 2, which is more Pythonic and has, it just always involves a lot of Googling and trial and error.
Yeah.
At least for me.
Yeah, cool. So then the other one that we really wanted to talk about was this Guitar Synthesizer tutorial, which is really awesome. And I want to note that you kind of in your wave file one, I think you already hinted at this, that you do a little bit of synthesis.
Yeah.
You were making sine waves and sort of calculating them, doing the math. And then you were I'm trying to think of all the different types of synthesis you were doing in there. Like you said, you were mixing, I want to call them notes, but pitches together to look at the beats. Was that an inspiration for you to get into other forms of synthesis, or were you already thinking about this in the past?
No, I think it was an inspiration. When I finished writing the wave tutorial and included the synthesis there, I remembered that I had a prototype of the Guitar Synthesizer that I wrote a long time ago.
Okay.
That I could take a few steps further and write in Python. So yeah, that's how the idea was born.
Some of the genesis that thing's been in the back of your mind for a long time and wanting to get into it. That's cool. To go from completely left field, what's your music background? Do you play an instrument currently?
I would say it's pretty minimal, my background.
Okay.
My musical education probably stopped in primary school when I attempted to play a flute. But that's about it, and I can barely remember it today, so that probably doesn't even count. Do I play any instruments now? Unfortunately not, but honestly, finishing that Guitar Synthesizer tutorial actually, at the end, made me want to pick up a real guitar or maybe like a ukulele, now that I have a rough idea of how these instruments work.
Yeah.
And I've heard that the ukulele is apparently great for lazy people who don't wish to put too much energy into, strumming strings. So maybe I should start with that.
Yeah, I have a couple. You might notice in the background.
I can see, yeah.
I lived in Hawaii for a little while and kind of grew to appreciate the ukulele, as they pronounce it. And what threw me off as being a guitar player for decades was like, okay, well, what's the string layout here? How should I play it? And it's actually not that difficult. If you know chord forms of a guitar, the one like thing that unlocked it for me, it's like, okay, it's just the top 4 strings. And I was going to bring this up because I have this argument with my wife about the idea of top and bottom strings. She always thinks of them physically, like you're sitting with the guitar and the bass strings are closest to you. If you're looking at them vertically, she thinks that is the top. Go ahead.
What if you're left-handed?
It should be strung the same way, but you could play it where it's still strung with the highest string. If you're sitting uh, right-handed, you would be at the bottom, the highest note pitch-wise. So anyway, my argument is I always say top is pitch. That's the top E, or the high E is that, versus like
the physical location of the string base.
Yeah, and it's an argument that we have because she plays guitar also. And so as we were doing like a cover band, and I'm like, yeah, you play it on the, on the low E. And so she thinks I'm thinking, the E that's the highest note on the bottom where she's playing it, that's the low E because it's lower vertically. I'm like, oh, God, this is killing me. Anyway.
I can totally see how this is confusing, because when I was, familiarizing myself with these musical theory terms.
Yeah, you got into tablature very deep.
Oh, man. The layout, the string layout was confusing, and it seems that the guitar tablature also uses a few different layouts. So
yeah,
plus you have different instruments, so it's all crazy.
Anyway, so I always call it high, would be like a higher pitched note. It's also higher numerically, as you kind of saw there, like it'd be like E4 versus an E2 or something like that, as far as tablature goes. So
there's one thing I wanted to ask you about, because I used to have this fascination with the saxophone ones.
Okay.
Which I really like to listen to, but there's this band from New York City subway called the Too Many Zoos. I don't know if you heard of them. They elevate playing on the saxophone to completely different level.
That's cool.
They call it the Brass House, which is quite a unique mix of different styles of music.
House like dancey kind of stuff?
Yeah, I guess.
Okay.
And I was considering, picking up a saxophone, but turned out it's a little expensive and frankly not so easy to play, from what I've seen on the internet at least.
Yeah.
So I was wondering if you, since you clearly have a musical background, I always see all these guitars in the background. So just wanted to ask you.
I've never done the wind instruments.
Okay.
I've met some amazing players over the years touring. It amazes me the variety of like saxophones. Like there's an alto, baritone, tenor, and they literally take different form then, right? To be able to have the length of the horn to be able to play. I always wonder how well that translates, because you kind of play them differently. You either play it like this, or whatever, all these different kinds of shapes. I know there's like a big part of it. You have to get this whole mouth thing going, right? You got to get your embouchure, as they call it, and figure out how to hold the reed properly and so forth. And I think, I don't know how much that would even translate to somebody playing something like a trumpet or another brass instrument that has a mouthpiece. I don't know. I wonder about it. I think guitar or ukulele would be a fantastic pick up and play kind of thing. You can just play it on the couch and so forth. And the volume definitely for an ukulele is great, because you can just, you're not going to disturb your neighbors or whatever. But which one were you, were you looking at? Gosh, I don't even know how much saxophones are. They're multiple thousands, I would guess, probably monetarily.
Yeah, I looked at some cheap ones, used ones, and they still were, I don't think it was, if it would be worth trying out without knowing if it clicks with me. So
yeah, if you're going to stick with it. They do rentals for kids, right, for school, and I don't know if that applies to adults. This episode is sponsored by Mailtrap, an email delivery platform that developers love. Mailtrap is an email sending solution with industry-best analytics, SMTP, and email API SDKs for major programming languages. And it includes 24/7 human support. Try it out for free at mailtrap.io. That's mailtrap.io. Okay, so part of what brought you to want to do this project is this thing that's been in the back of your head, and maybe we can talk the history of that. Like how long ago had you played with that? I'm trying to remember if you had said that already.
You mean the first prototype or the tutorial?
Yeah, the prototype.
Oh, the prototype. Yeah. Oh, that was like, I think I want to say 15 years ago. That was
okay.
My original implementation was a real-time synthesizer. So it had a user interface that looked like a piano keyboard. And it was made in a programming language called ActionScript and a web framework called Flex.
Okay.
So that framework was first released by Macromedia. I don't know if our listeners remember, but these were the folks responsible for the Flash player in our browsers before Apple essentially killed it.
Yeah.
And HTML5 took over the internet by storm. Later, that framework, along with the language, was acquired by Adobe to be eventually open sourced. And I think it's now under the Apache Foundation, but doesn't seem to be maintained anymore. And almost no one uses it these days because it runs on the non-existent Flash player. That said, it was a lovely web framework. I remember that building rich internet applications with lots of interactive visual components in Flex was a pure joy. And then moving to HTML, CSS, and JavaScript suddenly felt to me like a step backward.
Kind of clunky.
Yeah, they were so messy at that time because of the browser differences, lack of standardization, lack of support of certain APIs, and having to glue components that were made in different times for static web pages, whereas Flex was so well thought over from the start. It was tightly integrated with the tooling and followed naming conventions very consistently to the point I rarely checked the documentation. Plus, it worked nicely with Java as a backend. So that was 15 years ago. And now, since I use Python and NumPy to power the synthesizer, I've decided to drop the graphical user interface and instead focus on offline synthesis, as well as reading tabs from a file through the command line interface. So, yeah.
Okay. The real time wasn't something that's going to happen necessarily with Python.
No, that wasn't my goal. I just wanted to have a way to play a guitar tablature or tab, which is like a simplified musical notation, which is very, very popular.
Yeah. Yeah, it's a great way to get the ideas behind a piece of music to a guitarist who visually thinks of like the grid of the strings and frets versus it being in notation, which notation's hard because it like the range that a guitar can play is a little wider than what you would have, say, for like a monophonic instrument like a saxophone or a trumpet. I feel like that type of standard clef notation is a little easier to read. That's totally an opinion, but guitar is more like a piano in the sense that you have this kind of wider range, and then you're playing, multiple notes at one time across the strings. So
exactly, that's why I went with the piano layout for the visualization. Felt the simplest.
Yeah. So maybe we could kind of dive into this one. Is a little different from the WAV file one. That one was more of a tutorial. This one is formatted as far as real Python ease as a step-by-step project.
That's right.
And maybe you can just kind of go through what's all in there. You kind of hinted to some of it, but maybe we can kind of dive a little deeper into, what are some of the steps and what are people going to walk through?
Yeah, so it's a pretty long tutorial. Like you said, it's a step-by-step or project-based tutorial, as we sometimes call it. And it takes you from essentially nothing to having a fully fledged guitar synthesizer. It's not actually just a guitar synthesizer because under the hood, it uses an algorithm called the Karplus-Strong algorithm, which allows you to simulate a plucked string. So it doesn't necessarily have to be a guitar.
Yeah.
In fact, I simulate in this tutorial, I show you how we can simulate different kinds of plucked string instruments, including an acoustic guitar, but also there's an electric guitar, there's a banjo, there's a ukulele, and a bunch of others like a bass guitar. And then at the end, I combine them. So there's actually a little song that has like separate tracks with different instruments, and they play simultaneously. So there are a few components to this project, really. The first one is the core synthesizer, which probably takes the most space. Yeah, it's fairly low level. And then on top of that, the high level abstraction layer is the guitar tablature reader. I invented my custom YAML-based data format, but it's essentially a text-based format, not so different from like the plain text ASCII guitar tabs. So I used this data format, and I made a script that reads the notes or the chords from the YAML file. Then it just plays them, or actually it synthesizes them, saves them in an MP3 file or whatever data format you want, and then you can play it. It's pretty fast because it's all powered by NumPy. I was wondering, do I want to do this in pure Python, which would be cool and perhaps more elegant? But then I thought that that would probably end up unusable. I want it to be really useful, and so that you can actually use it. You can find a tablature online. I show a website called Songster.
Yeah.
which is this huge repository of Guitar Tablature. It is a community-driven website, so it has, I think, millions at this point, tablatures. So you can find the tablature of your favorite song, and it's just a matter of encoding it in my custom data format, and you'll be good to go.
Yeah. To kind of get people into it, you start by playing a little bit of audio from a couple of sort of famous video games that use a guitar.
Yeah.
You have an audio, a demo of Doom with the synthesizer playing the parts from that. So that's kind of your electric guitar with a little bit of a distortion.
Plus a bass guitar.
Oh, and a bass guitar with it. Okay, yeah. Mm-hmm. And then the one that I immediately keyed on, because I played this back in the day, was use the Diablo theme.
That was one of my favorite games. When I thought about, synthesizing something that would be recognizable, I immediately thought of Diablo soundtrack, because it's so well known and also apparently difficult to play when you try to play it on an actual guitar, right? I don't know if you tried it.
Yeah, it might be interesting tuning they were using or something, because I feel like it wasn't as standard. But actually, we'll probably insert some audio here so people can kind of check it out, what it sounds like, and get an idea of, at the end of this process, what you've built. Across this project, you are taking what you did in the WAV file one and kind of going a little bit further. You're now having to create an algorithm that generates this sound of the string being plucked. And I don't want to go into the details there. I'll include some links. So
we can go into details if you want to. I think the algorithm is it's beautiful, actually, because it's so simple, yet it produces these complicated sounds.
Sure. Well, you want to describe it then?
Yeah, sure. So the algorithm is based on a feedback loop. It starts by filling a small buffer with completely random noise, which provides a rich spectrum of frequencies that you can later filter. And you'll get the best results when you ensure approximately equal amount of those frequencies across the whole spectrum.
Okay.
And then the algorithm pushes those random samples through a low-pass filter, which, as the name implies, lets low frequencies pass, but over time attenuates higher frequencies more quickly. Then, after leaving the filter and being processed, each audio sample simultaneously goes to the output, which could be like a loudspeaker or a WAV file, and also back into the buffer in a round-robin fashion. So this is a circular buffer, which is also sometimes called a delay line, because it delays your original signal. And by tweaking the amount of that delay or the size of the buffer, you can tune the desired frequency that you want to synthesize. Yeah, in the tutorial, I explained how this algorithm really simulates the physical world, because when you pluck a guitar string, it starts to vibrate violently in seemingly random directions before it settles down at a particular frequency called the fundamental frequency. And that's what inherently makes your string sound the note that you perceive as a pitch. In real life, by changing the length or thickness of the string, you can tune it to a particular frequency.
Yeah.
So that's the algorithm in a nutshell.
Yeah. So the initial burst of noise is the exciter or whatever, in the sense that it's creating the pluck or the sound of a pick striking a string. And then the filter doing a couple things there. It's sort of shaping the noise. So to create those other instruments, let's say you talked a little bit about adjusting to create the pitches or the notes that are being played, but how are you altering how this works to create an ukulele versus an acoustic guitar?
Sure. So each stringed instrument differs in the number of strings. Like the classic guitar usually has 6 strings, whereas a ukulele has 4. Also, you can assign different pitches or different frequencies to each string. In fact, the same instrument can be tuned to different tunings. So you have something called a standard tuning for each instrument, and also a couple of alternatives. So I stuck with the standard tunings. So the first thing is you have to decide on the number of strings. Then you have to decide how you want to tune each of the strings to which frequency.
Okay.
And then you can also adjust the tension of each string a little bit by telling that low pass filter how quickly you want the vibration to dissipate, how quickly the energy should dissipate.
So like a decay, like how quickly.
Yeah, exactly. So there's a parameter that determines how that low pass filter will
Okay.
work. And how do you simulate different frequencies? Like I said, you modify the amount of delay in that initial buffer, which is usually very small. And this corresponds to also the length of the string. You can think of it as so.
Okay.
But that's not enough, because what you get out is a pretty artificial sound. I mean, it's kind of sounds like a string. It's maybe when you first hear it, you might be surprised and think to yourself, wow, it really sounds like a guitar. But when you want to build something more complicated and play like a song, then it doesn't sound like the real thing. So there's a number of things that you can do to improve the sound, and I left some suggestions at the end of the tutorial, so if people are interested, they can try a few different tricks. But I limited myself to using a library called Pedalboard by Spotify.
Yeah, I was going to ask you about that.
To simulate an electric guitar amplifiers, because the library comes with a bunch of filters and plugins and effects, essentially, that you can mix together. Yeah, so I used this library to simulate an electric guitar amplifier, as well as to simulate the soundboard, because a regular guitar has a sound hole, which for resonance, for improving the resonance,
right,
and it makes the sound richer because of the extra vibration and reverberation. You get a unique timbre of that instrument. So to simulate that, I use a technique called convolution reverb, which is a particular kind of filter that lets you make your fake guitar sound like a real one, essentially. And how it does is by using an impulse response, which is a very short recording of an actual real life instrument, which is really, really short, like a fraction of a second, but it's enough to mimic the spatial qualities or the echo, the reverberation of that soundboard. And you can apply it, and in theory, at least, it should make the instrument sound more genuine.
Yeah, and make it sound like it's in a space.
Right. I initially implemented that convolution reverb using SciPy, but since I was already using Pedalboard, I migrated to that library, since it already shipped with the necessary effect and plugin, and that also reduced the number of moving parts to worry about.
Yeah. Going to show my age, but I was working at the recording school back when this sort of technology came along of convolution reverbs, and they ship with a bunch of them. They're like, okay, we'll get this recording of the impulse inside of a church. We'll do it inside of a small room, inside of an airport, inside of a racquetball court, all these different kind of chambery kind of things. And one of the things that we learned is how we could actually create those ourselves, the kind of raw material sample, if you will, that was needed for it to do that. And then I watched a documentary about a guy who was really into this stuff, and he wanted to find the longest reverberation sound he could possibly find. And it was an underground fuel tank, basically, that was from like World War II. And it just is like this massive tunnel. It just goes on and on and on and on and on. And so he wanted to make sure he could record that to have like the longest reverb tail. it was very interesting to kind of watch, but the ideas behind it, obviously you don't want to have any other noises around. You just want to get that impulse and record it. But
I think what I found most exciting about this technology was when I found this recording of someone singing, and then you could choose like a real life place where you want them to sing, and it would add the right amount of reverb, and it really sounded as if that person was singing precisely that location.
Yeah.
That was kind of amazing, I think.
It's pretty cool. Yeah. The modeling technology, the particular one that you're using in this, is a little older. It's from like the 80s, but you said like it's very elegant, and I think it probably created the foundation for a lot of areas of this field of, so they call it physical modeling, like trying to like create things that can model things that are in the physical world. And I sent you a picture from this. I'm a big Logic user. I actually added a lot of the show on it, and Logic from Apple. they came out with a thing, they called it Sculpture. Basically, you could model whatever you wanted. Like you could just say, like, what's resonating? Is it made out of glass? Is it made out of wood? Is it made out of metal? How are you disturbing it? Are you plucking it, blowing across it, bowing it? All these different kinds of things. And then you could choose like where the pickup is. And it's just sort of fascinating. You can create just, instruments that have never existed, obviously, which is kind of a fun, you probably hear it in soundtracks all the time. These kind of wild instruments that kind of creating these atmospheres and things like that. But you can create guitars and you can create drums and things like a vibraphone and so forth. And you just have to kind of combine these different things together. But it has a wild interface. It's like, it would take you, several weeks just to kind of figure out what is this interface allowing me to do, all these knobs and dials and things you can adjust. But so again, I'm super fascinated in this subject. And so anybody's interested in like, oh, this sounds kind of fun. This is a great starter point, like you kind of play around with some of the synthesis here. I just did a story that came out last week about music information retrieval. And it's sort of the reverse of what we're talking about in a sense of taking a recorded piece of music, what chord was played, and analyzing what notes were there. And so it's kind of a related field. So I feel like there's a lot of that kind of in and out, like, okay, how could we create music? And then other ways of like, well, how can we analyze what's in an existing piece of music?
Well, actually, a pedalboard was made by Spotify originally, I think, precisely to teach computers to listen to music and then analyze it and bring back some interesting facts about it, like the tempo or maybe key or the note, like you mentioned. So the team that was originally working on that library is their machine learning and like sort of AI team that wanted to get some insights into music. So it sounds kind of similar.
Yeah. It definitely sounds like it's in that realm. And I mentioned a textbook and this set of Jupyter notebooks that basically get you into the ideas of it and kind of rip them apart. You use the pedal board initially in your step-by-step project here to do a little bit with the audio file stuff, kind of like to take some of the heavy lifting of writing out the file. Is that right? It generates an MP3 or what have you?
Yeah, so pedalboard also comes with this I/O package, which takes care of encoding and decoding. Well, in this case, it's primarily encoding. So it takes the synthesized amplitude levels, which are then normalized, and you remove the bias, and then it encodes it into an MP3 file. So you don't have to think about all the low-level details that I covered in the WAV tutorial, which is nice.
Yeah. I mean, if you're interested in learning those, they're there. And also you get smaller files. I guess when you think of a piece of music, audio can get pretty big, not quite video size. But...
And it's probably also faster since pedalboard is implemented in C++ mostly. So with some Python bindings. So it's pretty snappy.
This week, I want to shine a spotlight on another Real Python video course. It's titled Playing and Recording Sound in Python. So it really fits the theme of this week's episode. The course is based on a Real Python article by Joske de Long, and your instructor is Joe Totusco. He shows you how to use some of the most popular audio libraries to play and record sound using Python. By the end of the course, you'll know how to play MP3 and WAV files, as well as a range of other audio formats. Play NumPy and Python arrays containing sound. Record sound using Python. Save recordings or audio files in a range of different file formats. I think exploring how Python can work with audio is not only fun, but a great way to explore the creative side of Python. It also could help you add a new set of multimedia features to your projects. And like most of the video courses on Real Python, the course is broken into easily consumable sections and has code samples for the techniques shown. And all our lessons include a transcript and closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. We talked a little bit about the idea of teaching some Python concepts across this. Do you want to touch on some of the ones that you use in this particular tutorial that are kind of great for, students that are, hey, I want to learn a little more about how this works in Python, and then have something that's a little more tangible than just like a REPL session?
Yeah, so I think every tutorial is a great opportunity to showcase some of the interesting features in Python. And this one, there's plenty because it's a pretty large project, you can say. So in this one, I'm using a lot of type hints for static type checking. I'm also using protocols, which is another typing feature for a technique called static duck typing. Then I also use Python enums, data classes, structural pattern matching, and the walrus operator, which is also known as the assignment expression. And these features are some of these features were introduced in Python 3.10, others a bit later. So it's you can say it's cutting edge, the cutting edge. All of these features are covered on real Python, at least to some extent, and usually pretty well. So you can find relevant tutorials and video courses if you want to explore them. But these are like the low level details, low level features of Python, its syntax. Aside from that, I also spend a lot of time in the tutorial highlighting the benefits of immutable data types in this project. And I think immutable data types are great, and Python has no shortage of them. And they can save your skin. Otherwise, you'd probably waste a ton of time debugging your code.
Yeah.
I can say it from my experience for sure.
Cool. So one of the other things, technologically wise, you touch on using poetry
Right.
in this project. I think more near the end when you get into bundling everything together. Do you want to talk about that?
Well, actually, I don't use poetry a lot in this tutorial. I chose, well, first of all, for those who may not be familiar with poetry, it's one of many Python package management tools, which can help you manage your dependencies. And I chose it because I didn't want to waste time on housekeeping tasks like creating and activating a virtual environment or making sure to install your package before you actually run it. So Poetry has a very intuitive use command line interface, and it's pretty straightforward to create a new project, and you can just focus on implementing the code and not about all the other tasks around it. So that was the main reason why I chose poetry, but it's
Okay.
definitely not the only one. Another reason, so I introduced poetry very early in the tutorial. It's actually the first step when we create a project from scratch. It can scaffold the directory structure. It will create the pyproject.toml file, which is like this new standard in Python for project configuration, which I also use at the end to define an entry point, which is essentially a shell script that will delegate to one of your Python functions. So you don't have to prefix your module with Python, the command, the interpreter. You can just type the name of a command, which is almost magically appears in your shell, and it will run the right Python interpreter and run the right functions. That's why I chose poetry for this project.
Yeah. And along with that, you chose to use YAML to kind of organize your files for the guitar tabs. Why did you pick using that?
Well, if you're asking about the data format, the YAML file, I was considering different ones. So the obvious choices would be JSON, maybe for the older folks, XML, and then YAML. And all of them share some common features that I talk about in the tutorial. But ultimately, YAML is perfect, I think, for this kind of information because it has a neat feature. There are actually two features that you use together. They're called anchors and aliases. So what you can do is you can essentially declare a variable in your YAML document, and you can refer to it many times over later on in the document. And that is a huge space saver because most songs contain a lot of repeating patterns of chords and sections. So having to type them out in JSON or XML would be just so wasteful, whereas in YAML you have a very compact syntax for that, and I think it's a huge win for YAML in this particular context. At the same time, YAML, to be fair, YAML has some downsides, especially the older version. And honestly, I'm using the older library in Python for handling YAML, which isn't the best way to avoid some bugs, but at the same time, it's the most popular and simple to use. So I went with the PyYAML library, which is most common. But there are more reliable. If you need like type safety, then there are definitely better choices. But for this purpose, I think it was okay.
Yeah, cool.
And I'm not sure. You wanted to ask about the choice of the musical notation.
Yeah, I bet this was probably hard for you to sort of decide, like, well, how deep do I go into music theory as I explain this through there? Because, I mean, they're going to have varying levels of people with musical background. Was that something that kind of came across as you start to think about, like, okay, we're creating music here, or at least we're interpreting a piece of music? What went into that whole process?
Well, I looked at the Songster website, which I already mentioned, and I had to learn the notation. So most of the guitar tabs use a simplified notation, which only shows you where you want to place your fingers, but doesn't contain information about the rhythm. So what people typically do, they have to be either already familiar with the song that they're playing, or they would play like on YouTube or somewhere else the original song and play along to find the right rhythm. But on Songster, you first of all you have a built-in player, and then it also contains additional notation, which is conceptually similar to sheet music, which contains the rhythm. And I think for me, cracking that notation was actually the most difficult part. Learning about it. But yeah, I guess Songster was the inspiration for everything else.
So I wanted to touch on this. You have this description of yourself in the Real Python sort of bio section where you describe yourself as a polyglot programmer. What does that mean to you?
It means to me that I identify myself as a software engineer or a programmer who isn't attached to any particular programming language. Right now, for the past couple of years, I've been specializing in Python, but that doesn't mean I don't follow like other languages, or I'm not open to learning new languages. I think at the end of the day, a programming language is just a tool. Like
Right.
different programming languages come with different features, different pros and cons. So you should treat it as a tool. You shouldn't be too attached to any single programming language. Of course, there are some arguments against that. Like it's also helps to be an expert in one technology to be successful on the marketplace. But yeah, I don't feel attached to any particular language. Career-wise, I probably spend more time being a Java programmer, but I dabbed into many other languages, and I'm curious what my next language will be. So far, I'm super happy with Python, so I don't feel I need to make any changes. Plus, Python seems to be
Yeah.
very popular
Yeah.
these days, so I'm happy where I am right now. But that doesn't mean it won't change at some point.
Yeah. I got an email recently sort of thanking me for focusing on the Python community, but not making things tribal, meaning that I am open in the sense to having guests like Wes McKinney on who will say things like, it's not about R versus Python. It's about open versus closed source, or it's, all these other kinds of things that are involved in it. And I am definitely a polyglot as far as careers and so forth, but programming definitely. I just started in SQL, really. I mean, I started with BASIC a long time ago, but
Really, that was my first programming language as well.
SQL?
No, Basic.
Oh, BASIC. Okay, yeah, yeah. Anyway, I'm intrigued by that idea of polyglot stuff, and it's great that you're here building stuff at Real Python. Do you want to hint at anything else you're working on soon?
Mm, yeah, so I mean, I have a few things
Okay.
going on in the background. I think I don't know if we want to share this so early, but one of the things that I've been working on was the idea of a new content format that we would
Yeah, yeah.
publish instead of just tutorials, video courses, etc. So we've been experimenting with some coding challenges, which would engage our members even more. So the idea is to have sort of like a step-by-step project, but you have to solve it on your own first, and you would get also some automated feedback about your progress. So if you're stuck, if you can't move past one of the steps, then you get some hand holding there.
Yeah.
So I think that's one of the most exciting things right now that we've been playing with.
Yeah. I'm so intrigued by it, and I'm, we're not making any promises here. This totally depends on like how we can build this and deploy this and make sure that it all works on from all angles. But I know it's something that is been in the back of all of our heads for a while. Like this would be nice to do it. I think it's a common theme across many of the real Python core team members, the idea of challenges.
Yeah.
And we've wanted to do it. We've added quizzes. There's a very in-depth quiz even for this project-based tutorial here. So
this one was tricky because I didn't want the quiz to focus on the implementation details of this particular project. So instead it focuses more on the music theory that I learned along the way. So I was actually having a lot of difficulty finding the information that I needed for this project. So I hope that this tutorial as well as the quiz will serve as a nice resource for our members and readers.
Yeah. And I mean, there's lots of questions about the different types of Python structures and stuff that you use in it too. So yeah, cool. Well, I was going to mention this thing as kind of a joke because you mentioned that one song on ukulele. Is it Jason Mraz? I'm trying to remember who it is.
Yeah, the chorus.
Yeah. And I was going to say, are you familiar with the 4-chord song?
No, but it sounds vaguely familiar now.
Yeah, there's this thing called a 4-chord song, and there's a video on YouTube that's very popular by a group. They call themselves the Axis of Awesome. And it's like how all these songs use the same 4 chords.
I think I've seen that.
Yeah, you might have seen that. Yeah, well, that's one of those. The chorus of that song, those 4 chords. I'm like, I listen to it and go, hey, it's a 4-chord song. Anyway, I'll include a link to it so people can check it out. But it's very funny because it's like starts out and you're like, oh yeah, this is Journey, Don't Stop Believing. And then he switches to Can You Feel the Love Tonight? And then you're like, oh, wait. Poker Face? Okay, wait, what the heck? It's pretty wild. Obviously, they have to transpose them and all be the same key that they're in, but the chords are the same. And so anyway, it's very interesting. And they have to do like a double time version to be able to do the versions that are higher tempo and so forth. But it's pretty fun. Well, I want to thank you for coming on the show, Bartosz. It's really fun to talk to you again. And if people want to find out more of like what you're up to, I don't know if you're on social media at all.
I am. I regularly get messages on LinkedIn or through email.
Okay.
So I think the easiest way to find me would be through LinkedIn.
Okay. And then I didn't prep you for this, but I always ask these questions like, what's something that you want to learn next? Do you have something in mind?
Good question. Well, I think it would be appropriate for me to say that I want to learn how to play guitar or another instrument. I actually tried to play the guitar a long time ago by myself, so I didn't have any help. So I had no clue how to handle that instrument. But that was before the internet, so now I could perhaps use lessons from someone like you.
Yeah, I know that, or you got Songster. You ready to go there?
Ukulele would be nice. Yeah. But other than that, I think I'd like to learn to cook finally because my wonderful wife has been spoiling me.
Wow,
since we met. So yeah, she's lovely.
That's a passion I have. Partly, I don't know if I ever say this on the show that I'm a celiac, so I can't eat. I'm one of those gluten-free people. So I kind of need to cook for myself. And so I kind of thought about going to like culinary school. And then I said, maybe I'll just get a bunch of books or watch a bunch of videos. And so I've been dabbling much into that. What are the kinds of things that you're interested in cooking?
Right now, I'm reading a book called It Starts With Food, and I'm really into healthy food. So I'm trying to figure out my diet, and it would be nice to be able to just cook for ourselves the way you're supposed to. Yeah, so I guess the paleo diet is fancy these days, or some people call it the carnivore diet, I think. So
caveman diet or something like that.
So I'm trying this. Or also another one is keto diet.
Yeah.
But I think that would be too extreme for me at this point. So I'm just trying to figure out a diet that would be sort of aligned with that paleo idea.
Okay, cool.
But not super strict.
Nice. Yeah. My wife is decided to go down the vegetarian route. That added a new challenge to our cooking. So I still fire up the grill and have some meat from time to time. She doesn't shame me, but she won't enjoy it. So it's like, all right.
Yeah,
So I have to pick and choose.
I can relate. I mean, my wife was like that too, but she suddenly changed her mind and went eating again.
Yeah, totally. Yeah. Well, thanks so much for coming on the show again. It was really fantastic to talk to you.
Yeah, it was fun. Thank you for having me.
And don't forget, this episode was brought to you by Mailtrap, an email delivery platform that developers love. Try it out for free at mailtrap.io. I want to thank Bartosz Zaczyński for coming on the show again this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Paley, and I look forward to talking to you soon.